This is the question asked in GATE 2019 Electronics and Communication Engineering paper, in which you have given a z is an exponential random variable with mean 1 and its cumulative distribution function, that is CDF, is given by f of z of x, and you need to find out this conditional probability where probability z greater than 2 given that z is greater than 1. The NPTEL reference for this question you can find in Probability and Random Variables by Professor Aditya K. Jagannathan. So, the useful data for this question is that you should know the relationship between probability and CDF of a random variable. So, if you have given a random variable z whose CDF is defined by f of z x, where z is a random variable, then it defines that it is the probability of that random variable z less than equal to x. So this is a CDF definition in terms of probability. The second useful data you should know, that definition of conditional probability. So you have given that event B happens already, and you need to find out the probability of A if event B has already happened. So this you can write this one as P of A intersection B divided by P of B. So using these two useful data, you can solve this problem. So in the question, you need to find out the probability of z greater than 2 given that z is greater than 1. So this you can write by the definition of conditional probability as P of z greater than 2 intersection, you can back it out, then this becomes intersection with z greater than 1 divided by probability z greater than 1. So the intersection of z greater than 2 and z greater than 1, let's assume this is a real line in which here it will 1 and here it will be 2. So z greater than 1 is RHS of this real line, that is z axis, and z greater than 2 is RHS to 2. So the intersection point is nothing but z greater than 2. So the intersection of this z greater than 2 and z greater than 1 will give you probability of z greater than 2 divided by probability of z greater than 1. Now, you have given f of z of x equal to 1 minus e to the power minus x and 0, that this is if x greater than equal to 0, and this is if x less than 0. So this is nothing but you have given that probability of z less than equal to x, which is equal to 1 minus e to the power minus x and 0 for x greater than equal to 0 and x less than 0. So, but you need to find out the probability of z greater than 2. So for probability of z less than equal to 2 is 1 minus e to the power minus 2. But probability of z greater than 2 will be, you need to subtract this one from 1. So this is 1 minus probability of z less than equal to 2, which gives you e to the power minus 2. Similarly, you can find probability of z less than equal to 1 is 1 minus e to the power minus 1, and you can find out probability of z greater than 1 is 1 minus p z less than equal to 1, which is equal to e to the power minus 1. So substituting these two values in this conditional probability equation will give you e to the power minus 2 divided by e to the power minus 1, and it is e to the power minus 1, which is approximately equal to 0.37. So the correct answer for this question is 0.37.